Yes, ma'am. So let's look at the first doubt that you have sent. You want the name for this, right?
Yes, sir.
Okay. What is this? Where is the source of this question, ma?
Sir, from the handbook which I've given, sir.
Handbook, right? Very good, very good. Okay. So now we will find out what is going to be the nomenclature for this, right? So here, I hope you know. Suppose if I simply write like this. What do you think is the compound? Yes, ma'am. See here. This will represent a carbon, okay?
Yes, sir.
And this will represent one more carbon. This will represent one carbon. This will represent one carbon. Okay, ma'am? And one single bond between all those 4 carbon atoms. So when I write it, it will be like carbon, 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 carbon. Clear, ma'am?
Yes, sir.
The last group, right? The group here and the group here are methyl groups. Okay. So these two are methyl groups. Okay. The remaining are hydrogens to be filled by hydrogens. So now can you tell me what is the compound?
Butane, sir.
Butane, correct, ma'am? That's all. So now tell me only this much. Then what is the compound? This is one carbon, this is one carbon, this is one carbon. Understood?
Yes, sir.
And the
Propane,
N
sir.
carbon atoms are methyl groups, correct?
Yes, sir.
So how do you write it? N carbon atoms are methyl groups. 3 carbon atoms totally. The remaining has to be filled with hydrogen. So what is this?
Propane, sir.
Propane, that's all. Are you able to understand, no?
Yes, sir.
Okay, so now going by the same logic, right? So this will be carbon, 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 this will be carbon. Is it clear, no?
Yes, sir.
All these will be carbons. And in addition to that, you will also have this as carbon, this is also a carbon. Is it clear?
Yes, sir.
Yes, no? Good evening, Evelyn. Welcome.
Good evening, sir.
Good evening. Good evening.
Sir, I actually joined with phone, sir, and my front camera isn't that fine. Can I please be excused for today, sir?
Oh, is it, Evelyn? It will be better,
My
you know,
internet
because
is
our
down
shortly
actually.
Yogesh sir is also going to join. Is there any chance that you can log into laptop?
Sir, I was going to log in from laptop only, sir. The thing is that I don't know why the Wi-Fi is not working. And I connected
Oh,
through hotspot also and it's not working. And my dad is out actually right now.
oh, is it? Okay, okay, no problem, no problem. Okay, fine, fine, okay. Good
Sorry,
evening,
sir.
sir.
Sir, good evening, sir.
Yes, sir. How are you, sir?
Yeah, sir, fine, sir, fine, sir.
Very nice, sir. Sure, sir. Just 1 minute, we will start, sir.
Yeah, sir.
Sure, sir.
Sir, in the WhatsApp which you have sent, in that there are some circled, no, sir? Those questions,
Only the
right?
circled ones. Yes, sir. Correct, sir.
Yeah, yeah.
Sure, sir. Sure, sir. We will just complete this question, and then there are going to be some set of questions which the students have asked, like Evelyn has asked, that will be clarified. And then finally, again, we can, once that is over, we can discuss the other question which you have discussed. You have given me. Okay, Jero?
Oh, okay, sir.
Sure, ma'am. So can you understand how this is to be named now?
Yes,
If
sir.
you see, there are 2 chains, right? One chain is like 6 carbon atoms, correct? If you go like this, it is how many carbon atoms? 6, no?
Sir.
1, 2, 3. 1, 2, 3, 4, 5, 6. But if you go like this, right? How many carbons are there? 1, 2, 3, 4, 5, 6, 7, correct?
Yes,
You should
sir.
select the longest chain. So longest chain 7 carbon is there, means hept. And because triple bond is there, it is ine. And you should start the numbering from the carbon atom where the triple bond is closest. So 1, 2, 3, 4, 5, 6, 7. Correct? So second carbon atom, it is there. So 2 ion. And it is hept. Got it, ma?
Yes, sir.
And in the fourth carbon atom, what is there? CH3, CH2 group. Correct? So that will be 4 ethyl. So 4 ethyl hept 2 ion will be the answer. Is it clear, ma, Jerome?
Yes, sir.
Okay, ma. Good, ma. The other question on mathematics GP we'll discuss after the other doubts are clarified. Okay?
Okay, sir.
Sure, ma, sure. Just 1 second.
Good evening, sir.
Yeah. The first question you have asked is to define the concept of centripetal acceleration.
Sir, I think your voice slightly is lower than usual.
So now,
Okay, sir. It's audible. It's audible. Only thing is, if any chance that it can be louder, that will be better, sir.
okay, sir. Okay.
Sure, sir. Thank you, sir. Yes, sir. You can continue.
But just a minute, sir. By this Wacom is not connecting.
Okay, sir.
Some issues, I think.
What is that, sir? The audio device, sir?
No, the boards are the Wacom board which I'm writing.
The board is not working, sir.
Yeah, board is not working.
Probably you want to log out and then log in again, sir, and try.
No. That this device some pin problem, I think, sir.
Okay, sir. Okay. But right now you were able to write now, sir? Okay. So how do you do this sum? Very, very simple. So you need to find the sum of the sequence. Just observe what is done here. So we need to find the sum. 7 plus 77 plus 777, etc. up to n terms. Correct? This was your doubt. Correct, Jerome?
Yes, sir.
Yes, ma'am. Now, what you do is you can take something common out. What can you take common from 777, 777, all this?
7, sir.
Yes, so I'm taking 7 outside. So what do you get? 1 plus
1.
11 plus 111, etc. up to n terms. Clear? Now what do? We multiply and divide by 9. Correct? Because 1 plus 11 plus 111 plus 1111 is neither AP nor GP. Right? So I want to make it into a GP, correct? Or AP, right? So what I do is I multiply and divide by 9. So all the sums which are of this type, you will do the step. What is that step?
Multiply and divide by 9.
Yes. So when you divide by 9 and multiply 9, that 9 gets multiplied to all these terms. So 9 into 1, 9. 9 into 9, 11 will be 99. 9 into 111 will be 999. So on and so forth. Is it clear? The step is clear?
Yes, sir.
Yes. Next, what I'll do is, this 9 I will write it as 10 minus 1. 99 I will write it as
100 minus 1.
very good. 999 I will write it as
1000 minus 1.
and 4 9s that I will write it as
10,000 minus 1.
exactly. So what you just see what will happen. So when I write it like this, 9 I write it as 10 minus 1, 99 I write it as 10, 100 minus 1, etc. The sum of the sequence, what will happen? 7 by 9 into, instead of 9 plus 99 plus 999, etc. I'm writing it as what? 9 I'm writing it as 10 minus 1. 99 I'm writing it as 100 minus 1. 999 I'm writing it as 1000 minus 1, etc. So now you combine all these terms. 10. 1 second. Yeah, now what do? You combine these terms, 100, 10, 1000, all these you add together. Now what is the sequence, Jerome? Is it not a GP?
Yes, sir.
Yeah, correct. Common ratio is there. Then 1, 1, 1, if you add n times, how many, what is the number you will get? Like 1 plus 1 plus 1, 3 times if you add, you will get 3. 1 plus 1 plus 1 plus 1, 5 times if you add, what do you get?
5.
5. 1 plus 1, 100 times you add, you will get 100, correct?
Yes, sir.
1 plus 1 plus 1, if you add n times, what do you get?
N, sir.
N, that's all. And then this is a geometric progression. Common ratio, what is the common ratio? Tell me, Jero.
10, sir.
10, very good. Because 100 divided by 10 or 1000 divided by 10 is the last step. Last step is going to be, see, this is a GP formula, you know, A into R power n minus 1 by R minus 1. R is 10 and the starting term is also 10. So it will be 10 into 10 power n minus 1 by 10 minus 1, which is 9. Is it understood?
Yes, sir.
This entire sequence, you have written the formula. Is it clear?
Yes, sir.
And apart from that, there is a n here. And apart from that, there is a 7 by 9. Correct, ma?
Yes, sir.
So the final answer is what? 7 by 9 into 10 by 9 into 10 power 9 minus 1. Sorry, 10 power n minus 1 minus 9. So that is the final answer. Is it simple, Jerome?
Yes, sir.
That's all. Yeah, very good, ma. Very good. Yogesh, sir, are you back, sir? I will just check with sir 1 minute, ma, before we proceed further. Welcome, everyone. Just give me a minute, ma.
Yeah. Students, look at this question. When a moving bus suddenly stops, passenger on its fall in the forward direction. This is due to. Now, before going to the options, you know the meaning of the inertia. Inertia means it is the inherent property of the moving body which continues to be in a state of rest or in a state of motion. Now, look at the question. Bus is moving. Bus is moving and it suddenly stops. When the bus is moving, can you tell me which type of inertia will be there? It's inertia of rest or inertia of motion? Bus is moving. Inertia of
Motion.
motion. And that bus is going to stop what? Bus is going to stop what? Immediately starts to stop. So what happens to passenger?
He falls, sir.
Yeah, it is falling forward, right? Correct,
Even
no?
you can ask, what is your doubt in this?
Sir, I was just confused, sir. I thought the answer is inertia of motion.
Correct.
But
Option D only. Inertia of motion only.
Sir, but the answer is given as inertia of rest.
No,
So
it's wrong. It's wrong. It's wrong. That is what I'm saying. If the bus is moving, what type of inertia will be associated?
inertia of motion.
Inertia of motion. Because the bus suddenly stops, but the passenger continues to move in the forward direction, right?
Yes, sir.
So it is inertia of motion. Option A is not correct. Actually, right answer is option B.
Yes, sir.
Yeah, inertia of motion. Option B is right. But similarly, if the bus, which is at rest, if it suddenly moves, the passenger will fall backward, right?
Yes, sir.
That is inertia of,
Rest.
yeah. Got it?
Yes, sir.
Yeah. So next question, sir. Yes. Conservation of linear momentum in a collision between the particles can be explained from conservation of linear momentum in the collision is between option A, conservation of momentum, Newton's first law, Newton's second law, Newton's second law, and the third law. Can you tell me the linear momentum conservation is proved by which law?
Conservation of momentum.
Which law? Look at this. You know that whenever the two bodies are going to collide, the collision before, momentum before collision is equal to the momentum after collision, right?
Yes, sir.
During the collision, the force acting on the first body will give the same reaction to the second body, right?
Yes, sir.
So there is an equal and opposite reaction, isn't it?
Yes, sir.
So when there is an equal and opposite reactions, it's going to get. It is which type of law? It is third law or second law?
Third law.
Yeah, it is third law. But in the options, they have not given only the third law. They are also telling that is it combined with the second law? What is the second law tells?
Rate of change of momentum is directly proportional
You
to the
cross multiply that. What is F into delta T?
impulse.
What is the other name for impulse?
Change in momentum.
Yeah. So we are proved that the momentum is conserved. That force into time will give us Newton's second law, right?
Yes, sir.
So it is the combination of both Newton's second law and
Newton's third law.
third law. But actually, based on conservation momentum, we are equating every action is equal and opposite reactions. So you have to tell Newton's third law.
Sir, but in that book, the answer is conservation of momentum, sir. And in some places, the answer is given as second and third law. So here both were given, so I was confused.
Yeah, wait. Just, sir, I'm not getting the screen.
Just 1 minute, sir. I was just adding another slide, sir.
Yeah.
Sure, sir. Yes, ma'am. Sir, I also think that it is both Newton's second law and third law. Correct, sir?
Correct. So Newton's second and third law only, sir.
That's all.
Because conservation of momentum is the proof we are giving. The answer can't be conservation of momentum only.
The conservation of momentum is explained using which law? So that is the idea, Evelyn.
Yeah. That is the idea. That is second and third law only.
So B option is the right option, sir.
Yeah.
Sir, because in that book, again, it was A option. So again, I got confused between them.
Sometimes, errors are there.
Fine, sir.
Am I right, sir?
Correct, sir. Correct,
Yes,
sir.
we can move on. Sir, is the question visible, sir?
Yeah, sir. Yeah, look at this. Bullet is fired in the horizontal direction from the top of a tower 19.6 meter tall. Bullet fall 500 meter away from the base of the tower. Calculate the velocity of the bullet. Yeah. In which direction the bullet will move up? That is the basic condition actually. In which direction it will move? What is the path? Yeah, exactly. Sir, show me that vertical distance 500 meters. That's sorry, 19.6. Yeah. So it is a parabolic path, right?
Yes, sir.
Yeah. Now, when it reaches the base of the tower, what is the distance it has covered? Horizontal distance.
500 meters.
Exactly. Now, can you tell me the time taken to cover that vertical height and the horizontal distance is?
Time of flight, sir.
Not time of flight. I'm talking the time taken to cover that 19.6 meter and the time taken to cover that horizontal distance 500 meter will be same, no?
I didn't understand, sir.
No. What I'm talking, The particle is coming down, right?
Yes, sir.
What is the vertical distance it has covered?
19.6.
Yeah. What is the horizontal distance?
500.
So to cover that horizontal distance and vertical distance, what is the time? It will be same or different?
Same, sir.
Yeah, that is what I'm saying. So you have to find that time, right?
Yes, sir.
Yeah. How to calculate the horizontal distance and the vertical distance here? Look at the data. Vertical distance they have taken as what? Sir, you write T equals to root of 2h by g, sir. T equals root of 2h by g. What is height covered up here?
19.6.
Yeah. What is g value?
9.8.
Please substitute that and find what is the time value. You got it?
Yes, sir.
Yeah. This is the time taken apart. But what they are asking? Velocity of the bullet, right?
Yes, sir.
Yeah. How to find the velocity? It is nothing but the distance by the time.
Yes, sir.
Sir, why we have to use distance by time? Because for the x-axis, there will be no acceleration, right?
Yes, sir.
So there will be no acceleration. So ax will be 0.
Yes, sir.
Yeah. So how to calculate what is the velocity? U into t. Here theta is 0 degree because bullet is fired horizontally. So theta value will be 0.
Sir, how is theta 0, sir?
How the bullet is fired? Horizontal direction, right?
Yes, sir.
What is projectile motion? The angle theta is the angle made by the bullet with the x-axis. But theta is not there now because it is fired horizontally. So theta value will be 0.
Okay, sir.
Yeah. This is the horizontal velocity. Clear?
Yes, sir.
Now, you tell me what is the vertical velocity?
U sine theta.
No. Direct formula root of 2gh.
Yes, sir.
So what is the vertical velocity? You can use Vy, sir, or Vy.
Sir, what, sir?
What is the vertical velocity? Because when it hits the ground, there will be both horizontal velocity as well as vertical velocity, isn't it?
Yes, sir.
So you find what is vertical velocity? Root 2gh. Direct formulas are root 2gh. Yeah. Okay. Yeah. What
Yes.
is the height? What is the g value? You know.
Yes, sir.
So you find what is that vertical velocity?
Yes, sir.
How much you'll get? 2 into 10. You can make use of 10 because g is given in the data as 10. Okay.
Yes, sir.
Now, how many velocities are there when it hits the ground? When bullet hits the ground, how many velocities are there?
2, sir.
Yeah. What is Vx you got? Horizontal velocity? What is the horizontal velocity you got? $250?
Yes, sir.
Yeah. What is the vertical velocity you got?
19.6.
You can make it as 20, sir? Yeah, good. How these two velocities are acting apart?
Perpendicular to each other.
How to find the resultant velocity?
Root of Vx square plus Vy square.
Yeah, exactly.
The method clear, Evelyn?
Yes, sir.
Any doubts are there? Please ask.
No, sir, I understood.
You understood
Yeah.
completely?
So, please remember, when you are talking about projectile motion, you have to talk in both the case, along x-axis as well as along y-axis.
Yes, sir.
Yeah.
Just 1 minute, sir. I'm sharing the next.
Yeah, sir. Yeah, sir.
Can you see the screen, sir?
Yeah, sir. Look at this. The ceiling of the long hall is 25-meter height, right?
Yes, sir.
What is the maximum horizontal range or horizontal distance that ball can be thrown with what speed?
40 meter per second.
Yeah. You show me the thetas are there.
Yes, Evelyn, you can ask your doubt. What doubt you have?
No, sir, like finding the value of theta, sir. Like in this case.
For that, we have to make use of that sine function's natural sine value. If you have logbook, you can open that. And that dimension. Yeah. Surface tension. Now, actually, if you take the water on the horizontal surface, what type of shape it will take?
Spherical, sir.
Yeah. When it takes a spherical shape, it tries to occupy the minimum surface area. Why it always tries to keep the minimum surface area? Because it has some property in the liquid. That property is what we called as the surface tension. So how do you define surface tension? It is the property of a liquid or a fluid. It is the property of a fluid due to which it tries to keep the minimum surface area. Which tries to keep minimum surface area.
Any doubts in this definition, Evelyn?
No, sir, not in this one. Sir, I had a doubt in that part where they say that surface tension is equal to F by L and that force
Per
thing. So
unit
why?
length. How it is measured the surface tension? Now the surface tension is going to be measured always the force per unit length.
Yes, sir.
Surface tension is equal to force per unit length. Sir, what is that length? Suppose if you consider the water drop on the surface you can draw one imaginary line.
Yes, sir.
On that imaginary line, there will be some normal force is going to act.
Yes, sir.
How much that force acting per unit length? That force is what we called as the surface tension.
Sir, so how does this water occupy the minimum area, sir?
Because if it is a spherical in shape, the sphere is itself is having a minimum area. If you go with ellipse or any other shapes, it is going to be more than that. Because there will be a inelastic membrane inside the liquid, whatever the fluid particles are there, all that fluid particles are tightly bound. All the fluid particles are going to tightly bound with an attractive force. Because of that attractive force, all the molecules will come closer. When it comes very closer, there will be a minimum surface area.
Okay, sir.
So for a given volume, the surface area, if you compare for all the possible three-dimensional figures, sphere will have the minimum area.
Minimum area.
Yes, sir.
So because of those forces, right? So it tries to occupy minimum area.
Okay, sir.
Dimension, are you clear, Evan? Any doubts in dimension?
No, sir, that I understood.
That you understood. Okay, good. Just 1 minute.
How does the viscosity of the liquid and the gas vary with the temperature? Actually, in the coefficient of viscosity for liquid, it is inversely proportional actually. As temperature increases, the coefficient of viscosity of the liquid decreases. But in the case of a gas, it is directly proportional. So as the temperature increases in the gas, the coefficient of viscosity increases.
Sir, so in both the cases, that coefficient of viscosity is directly proportional to the time, right? Not the root T.
No, not the time. They're talking about temperature.
I mean, sorry, yeah, temperature.
No,
Is that
no.
proportional to T, no, sir, in case of gases?
No. That is velocity of sound in the gases. Here they're talking about viscosity. So viscosity is denoted by the symbol eta.
Yes, sir.
Actually, there is one equation called eta equals 1 divided by 80 plus bt square. 1 divided by 80 plus bt square. This is called Slotty equation actually. This equation is not there in the NCERT syllabus, Appa. This is called the Slotty equation. According to this Slotty equation, N is inversely proportional to temperature here.
Yes, sir.
Yeah, in NCERT book, they have not given any expression. Just in general, they are putting the variation of viscosity. Please remember that. In the case of liquid, it decreases. In the case of gas, it increases.
Okay, sir. Sir, actually, over here, no, sir, like in the first case, like for liquids, it's given that eta is inversely proportional to 1 by root T, sir.
1 divided by?
Root T.
It is not 1 divided by root T. It is something like 80 plus bt square. It is the Slotty equations.
Okay, sir.
So when you answer even without writing the equation, because it is not in NCERT, you can write only the relationship.
Fine, sir.
Yeah. Whether it's increasing or decreasing, only that you can mention. Am I right, sir?
They will ask it like that only, sir. They won't ask the relation and all.
Oh, sure, sir. So better not to write the relation. Better to only give whether the trend is decreasing or increasing with temperature.
Yeah. Because it's not there.
Yes, sir.
Sure.
Yeah. Now, a cubical ice box of side 30 centimeter. 30 centimeter side. It's a cubical box. Thickness is 5 centimeter. 4 kg mass of ice is put inside the box. They are expecting to find what is the amount of ice remaining after 6 hours.
Yes, sir.
What is the concept here? First,
Thermal
you have to,
conductivity.
first you have to find what is the mass is there.
Yes, sir.
How to calculate the mass? It is amount of heat given to the latent heat, right?
Yes, sir.
So M is equal to Q by L.
Yes, sir.
How to find Q?
From thermal conductivity.
Very good. You know the formula for Q, that is Ka, change in temperature into time divided by the thickness. D represents thickness here.
Yes, sir.
What is the thickness they have given?
5 centimeter.
Yeah, 0.005.
Yes, sir.
How to calculate the area of the cube? Side square, no. In the cube, all the three sides are same.
Yes, sir.
So
6
side is
is
given
square.
as 3 centimeter, 30 centimeter, sorry.
Yes, sir.
So what is 30 centimeter? It is 0.3 meter, right?
Yes, sir.
So what is the area? 0.3 into 0.3.
Sir, this is the part I had the doubt in, sir.
Ah,
The same question was given elsewhere, and in that case, they calculated the area as surface area of a cube, 6a square. But in this case, it's just area of a square of side 30 centimeter.
when they are talking about the three-dimensional from all the faces, if they are conducting, if it start evaporating, because here we are taking the change in the temperature, right, between the two faces.
Yes, sir.
Only in that case, you have to consider the area as side into side.
Okay, sir.
If it is having in all the three sides, from all the surfaces, if it is start evaporating, then you have to take 6 times.
Sir, in that case, also the same question was there, so the exact same question. But in that case, they calculated it as 6a square, and here only is area of a square.
No, only you have to take the area of the square here because the heat is exchanging between the two surface.
Okay, sir. And sir, in this case, we don't have to convert the temperature to Kelvin, sir.
No need. Because the change in temperature, either in degree Celsius or in Kelvin, it will remain same, no?
Okay, sir. Fine.
Change in temperature, either in Celsius scale or in Kelvin scale, remains same.
Yes, sir.
Yeah, exactly. 5 degrees Celsius, same as 5 Kelvin.
That was the main doubt, Evelyn.
Yes, sir.
Okay.
Sir, so in the exam, if we get this question, it's just area of a square, right?
No, you have to go with the area of the square only, like side into side.
Yes, sir.
Yeah, in this, what is the doubt here?
Sir, I didn't understand this, sir.
Okay. How much heat is required to convert 10 gram of ice at minus 5 degrees Celsius into steam at 100 degrees Celsius? They're involved with three concepts here. One is specific heat of ice,
Yes, sir.
then latent heat of steam, and latent heat of fusion, and specific heat of water. So for all the four cases, you find what is the heat energy supplied.
Yes, sir.
For specific heat, what's the heat energy formula?
Q is equal to ms delta T.
Yeah, this is for which case? For ice.
Ice. Yes, sir.
10. For water, MSW delta T.
Yes, sir.
That is Q3.
Yes, sir.
These are the two energies with respect to specific heat.
Okay, sir.
Now, there is a latent heat also.
Yes,
For
sir.
latent heat, how to find the energy, appa? Mass into latent heat, right?
Yes, sir.
So mass into how many latent heats are there?
2, sir.
One is fusion, the another one is vaporization.
Yes, sir.
So M into LF and one more case M into LV. So in 4 different cases, we have the heat energy involved.
It is clear now, Vivlin?
Sir,
Yeah, tell me, appa.
sir, so in the first case, we are calculating the specific heat of ice, and then we have to calculate the latent heat of fusion when it's converting to water,
Okay,
and then the specific heat of water, and then latent heat of vaporization.
correct.
Okay, sir. So in this specific heat of ice and water, sir, that time we should take the temperature from which we are converting it, sir, like 5 degrees to 100 degrees Celsius.
No. Sir has written here. First, we are converting from where to where?
-5 to 0
So what
degrees.
is the change in temperature? 0 plus 5, minus of minus.
Fine, sir.
Yeah.
Yes, understood.
Okay.
Just 1 minute, sir. I'm just loading the another next question. I think next question is here itself, sir.
Yeah. Look at this. A steel tape 100 centimeter long is correctly calibrated for temperature 27 degrees Celsius. The length of the steel rod measured by this tape is found to be 63 centimeter on hot day, when the temperature is 45 degrees Celsius. What is the actual length of the steel rod on that particular day? So basically this question is based on the expansion of the linear expansion of the rod.
Yes, sir.
In this, what exactly you have the doubts?
Sir, I didn't understand the entire thing, sir.
Okay. First tell me what is the initial length of the tape?
100
Yeah, you can take Li, length of the 100 centimeter.
centimeter.
Because of that change in the temperature, there will be an expansion, right?
Yes, sir.
You tell that expansion is delta L. Yeah. What is that formula for delta L in terms of alpha? Alpha, original length, into change in temperature.
Yes, sir.
Yeah. So you will get the final particular length, That is 100.0216. Now,
Sir, why is there this L1 plus alpha 1 into delta T, sir?
no, what is the original length?
L, sir.
L. Yeah. Because
Yeah.
of the increase in the temperature, there will be expansion. No.
Yes, sir.
That expansion I'm taking as delta L. What is that final length? Initial length plus the expansion length.
Okay, sir.
Now, finally, they are telling what is the actual length on that particular day. That is nothing but L dash by 100 into 63.
Sir, I didn't understand, sir.
See here, original length we got 100 centimeter for 27 degrees Celsius, right?
Yes, sir.
But we want it for what temperature?
45.
Evelyn, two things are there, no? One is steel tape. Steel tape is measuring the steel rod, correct?
Yes, sir.
So steel tape also is expanding, correct?
Yes, sir.
So steel tape, instead of 100, if it is 100 centimeters, actually how much it will be now?
100.0216.
That means, suppose if that steel tape is measuring 63 degrees, 63 centimeter, actually how much will be that length? It is like one chocolate, 2 rupees, two chocolates, how much?
Sir, I didn't understand this, sir.
No, wait. 100.0216 centimeter is the actual length after expansion, right?
Yes, sir.
Yeah. This is taking for which temperature for 100 degrees Celsius? I mean for 100 centimeter. For 100 centimeter, what is the increased in length?
Yes, sir.
For 100 centimeter, what is the increased length?
100.
0.0216.
Yes, sir.
Now we want it for what length? 63, no?
Okay, sir.
Yeah, sir has written the table. Look at that. For 27 degrees Celsius, 100 centimeter. If I take it for 45 degrees Celsius, it will become.
So basically we are finding the expansion in the length of the rod at 45 degrees and
Correct.
then finding it for 63 centimeter.
Correct.
Okay, sir. So in this case, the final expansion is the original length, which is 100 plus delta L.
Correct.
Okay, sir. Yes, sir. Now I understand.
Yeah. What is given? Thermal capacity of
40 grams of
40
aluminum.
gram aluminium.
Yes, sir.
Specific it is given, right?
Yes, sir.
0.2 calorie per gram per Celsius. What is thermal capacity? Just M into C.
Yes, sir.
40 into 0.2. It is 8, I think.
Yes, sir.
Is it clear, Evelyn?
Yeah, sir. I didn't know the concept behind this.
Yeah, thermal capacity is 40 gram and specific heat they have given. You have to find thermal capacity.
Yes, sir.
Unit will be calories per Celsius.
Yes, sir.
You're able to see the screen, sir?
Yes, sir. Yeah. Look at this diagram, Evelyn. Whenever the particle is moving in the circular track, let us say initially the particle is at A.
Yes, sir.
When the particle is at A, I will give the tangential velocity. Let V is the tangential velocity.
Yes, sir.
In which direction I had given that tangential velocity? Horizontal.
Yes, sir.
Yeah. Because of that velocity, the particle has moved to the another point B in a short interval of time T.
Yes, sir.
When the particle has reached the point B, can you tell me what is the angular displacement?
Theta.
Very good. Now, at the point B, can you resolve the components there into two?
Yes, sir.
One is vertical, the another one is horizontal.
Yes, sir.
Can you tell theta alternate angle
Yes, sir.
between the vertical green color and OB?
Yes, sir.
So mention the theta there, sir, between vertical line green color and OB line. Yeah, yeah. If that is theta, between the green color and the blue color V, that is 90
Yes.
minus theta, no?
Yes, sir.
Yeah. So what is the angle between the blue color V and that horizontal green color line?
Theta.
Very good. Theta. Yes. Now tell me what is the horizontal component here?
V cos theta.
Very good. What is the vertical line?
V sin theta.
Very good. Now, sir, in the right side, you can write at the point A. At the point A. Here, yeah, at the point A. Evelyn, tell me what is at the point A, what is horizontal velocity?
V cos theta.
No, only V at the point A. At the point A, we have only horizontal.
Okay, sir.
What is vertical velocity at the point A? Vy?
0.
Very good. Similarly, at B. At B,
Yes, sir.
what is horizontal velocity?
V cos theta.
Very good. What about V vertical?
V sin theta.
Yeah. So this is at the point B. Now,
Yes, sir.
calculate the change in velocity along x-axis. I mean, along horizontal. Change in velocity,
Yes, sir.
delta Vx. It is V cos theta minus
V
V.
minus. Okay, sir.
Since theta is very small, we can take cos theta value as 1, right?
Yes, sir.
So V cos theta minus V becomes V minus V.
Yes, sir.
So what is V minus V?
0.
So what is the change in velocity along x-axis?
0.
So what is the acceleration along x-axis?
0.
Very good. Now, do the same concept for y-axis now. What is delta Vy, change in velocity?
V sin theta minus 0.
Very good. V sin theta it is, right?
Yes, sir.
What is if theta is small, sin theta is theta? No.
Yes,
Sin
sir.
theta by theta is 1.
Yes, sir.
No, sin theta is theta, sir.
Yes, sir. Yes, sir. Sorry, sir. Theta is very small.
Then sin theta is theta.
Yes.
So what is delta Vy?
V theta.
Very good. Delta Vy. You can write it here, sir. Above space at the point even. Yeah. So what is the change in velocity along Vy? V theta. Now tell me
Yes.
the definition for acceleration, Appa.
Change in velocity by time.
Very good. Acceleration is change in velocity by time.
Yes, sir.
That is V into theta by t.
Yes, sir.
What is theta by t, Appa?
Omega.
Very good. In the place of omega, we can write it as V by R.
Yes, sir.
In the place of omega, V by R. So what is
Yes.
V?
V
So what is the formula for
square
acceleration?
by R.
That's
V square by R.
yeah. So only the concept is you have to find what is the change in the velocity along x-axis and what is the change in velocity along y-axis.
Yes, sir.
So that clearly tells there will be an acceleration because of the vertical component. That acceleration is given by v squared by r.
Yes, sir. Excuse me, sir.
Yeah, tell me, Appa.
Sir, can you just send me a screenshot of this, sir?
Sure, Emily.
Yes, sir.
Right away, I'll send you. Okay.
Yes, sir. Thank you, sir.
Sure. Emily, I've sent you.
Yes, sir.